Hey everybody, welcome to class today or homework or whatever you end up using this video for, even if it's just for extra help. But today I'm going to kind of review the percent equation with you, and I'm also going to show you a working smarter not harder method. So today we'll be talking about sales and discounts, which decrease the amount you're paying, basic percent problems, so it depends upon whether we're finding the part, the whole, or the percent. We're going to find mark up, markdowns, and then we're going to do sales tax, which increases your bill, and tips, which also increase your bill. So basically, markdowns, discounts, and coupons are the only things that lower your bill or how much money you're talking about. Let's get started and introduce the percent equation. The percent equation is a beautifully simplified way to find percents. So you guys used the formula last year. This year we want you to start using the equation because it's a more math mature way. It says the part equals the whole times percent over 100. That's because here you need to have your percent either as a fraction or as a decimal. We don't care which way, just as long as you have it one of these two ways. Please remember, you should never be touching the percent button on your calculator. The reason for that is it disappears after this year and then you're not going to know what to do. So it's definitely a skill to know that you cannot use a percent as it stands and you must convert it to a fraction or a decimal. All right, let's keep it simple. Let's go into the simple percents first. So we'll start with number 7. Notice it says what is 7%, so that's clearly our percent of 78. You may have heard that the part is also known as the is, or even the change in some cases, and the whole is the of. So once we identify what we have, it actually is quite simple, and we're looking for the part because it says what is. I often like to do part, whole, percent off to the side so I can identify each piece. The part is our unknown, which we use variables to represent, and I'll use X. We use variables to represent numbers we don't know. The whole is 78, and the percent is 7 out of 100, or 0.07. Now we're going to rewrite our percent equation, so part equals whole times percent out of 100. We're going to replace the information we know, which the part we know is X, we know our whole is 78, and we know our percent would be 7 out of 100. Now we simply have to recalculate. There's nothing to do for the X because it's already by itself. So all we have to do is 78 times 7 hundredths. Oh, I wasn't typing, so let me get my calculator really quick. So we have 78 times 7 out of 100 gives us 5.46. So our part, or the is, our final answer here is 5.46. As we begin this problem, the first thing we're going to do is we're going to do part equals, whole equals, and percent equals. As we read it, we should identify what we have. So we have 48 is. As soon as you see the word is, you know you're looking at the part. Let's label it. 16%, we know that that's our percent, so we know it's 16 out of 100, or 0.16. Of what number? Who knows? Not me, but we need to find out. And if it's something we don't know, we need to represent it with a variable. Now we rewrite the percent equation, which is part equals whole times percent out of 100. Now we need to replace, so we're going to replace what we know and solve for what we don't. We know our part is 48. We don't know our whole. We're using X to represent it. And I'm going to use 0.16 here as my percent. You can use 0.16 or 16 out of 100, whichever you prefer. I prefer 0.16. It's a little bit easier to work with. Now, how can we get this X by itself on this side of the equation? We have X times 0.16, so in our recalculate step, we need to get the X by itself. We need to get the X by itself. How do we undo times 0.16? We need to get the X by itself. 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 Well, we divide by 0.16 because that's the opposite of multiplying. Whatever we do to one side, we have to do to the other to keep our equation balanced. On the right-hand side, we have just x left, and when we do 48 divided by 0.16, we get 300. That means our whole, or of what number, is 300. Sometimes we also think of this as the original. Original. So that could be change, is, original, of, and then your percent is always your percent. All right. Let's try this again. Again, we started with part, whole, percent. It's a great way to start the problems. Trust and believe. 21 is, as soon as you see that, you know that's a part. What percent? Who knows? I don't. We're going to use a variable to represent it. Of 30, that's our whole. Of gives it away. Now we need to rewrite, replace, recalculate. Start with part equals whole times percent out of 100. Then we need to replace. The part is 21. The whole is 30. And we don't know our percent, so we'll leave it as x. For our recalculate, we need to get this x by itself. So how do we get an x by itself when it's times by 30? Well, the opposite of times 30 is divided by 30, so we need to divide both sides by 30. When we do that on the right-hand side, we get x equals, because the 30s cancel out, 21 divided by 30 is 0.7. Now, I know what you're thinking. You're probably like, yes, I'm done. This is awesome. But you're not, because 0.7 is not a percentage. We need to then take this number and times it by 100 to get our percent of 70. 70%. Or you could use the shortcut by simply, moving the decimal point 2 places to the right. Okay, now that's straight up math. Let's get into some real life stuff. Come up here. It says a store buys guitars from a manufacturer at a wholesale price of $225. Now think about it. Okay, let's read the rest to decide if this is a part or a whole. The store's markup, I always like to put increase, is 85%. What is the sale price, aka the new price, of the guitar? Given this information, I can infer that $225 is my whole because that's my original amount. And then the store marks it up from there. So if we're going to identify our part, whole, and percent, our part is unknown, so that would be x. Our whole is $225, and our percent is 85%, or 85 out of 100. Now we can jump right to our rewrite, replace, recalculate. We got part equals whole times percent out of 100. Our part is x, our whole is 225, and our percent, I'm going to use it as a decimal, 0.85. For the recalculate step, we're lucky here. We don't actually have to do any solving. We can just actually multiply. So 225 times 0.85 gives you 191.25. Now, for this particular problem, we're not finished. This number right here represents the markup. Does it make logical sense that if we're marking up a price by 85%, people are now paying less? No, and that should be a trigger to you that you're not finished yet. If it's a markup, it's increasing the price of the guitar, which means you're adding. Therefore, we have 225 plus 191.25 for a grand total cost of $416.25. We can write a target statement that says the new or the sale price of the guitar is, and then we could put our price there, $416.25. Now that makes sense because it's higher than the original. Now, can I show you a working smarter, not harder way? If we have the whole, that would be 100%. And we already know that the whole is 225. But then we said we're marking up, aka we're adding on 85% more. And that gave us the 191.25. So now we have our two parts. We put them together to give us the 416.25. What if we put together our percents? What's our overall percent? Well, 100 plus 85 is 185%. So the working smarter, not harder way is to understand, okay, if this is an increase, then what I can do is add it on to 100%. I can take my percent and add it to 100. And then I can use that as my percent. So when I do my part whole percent, here I can do 185 out of 100. I still have my whole of 225, and my part here is still X. Now watch what this does to the problem. Notice here we had to do all of this, get an answer, add it, get a final answer. Watch what happens here. Here, you get part equals whole times percent out of 100. Our part is still X, our whole is still 225, and our percent this time is 185 out of 100. Now when you put this in your calculators, look at the magic. Like, pause the video, put this in your calculator and see if you see the magic. Hopefully you see that when you put this in your calculator, this gives you the final answer of 416.25 right off the bat. So this working smarter, not harder way eliminates this additional step of adding, and it eliminates the possibility of you forgetting to add or subtract. So the working harder, not smarter method is if you're increasing, you add to 100%. What do you think it is if you're decreasing? Hopefully you thought you subtract from 100%. So this is the working harder, not smart, no, working smarter, not harder, silly, working smarter, not harder method. If it doesn't make any sense to you, then don't use it. If it does make sense to you, by all means, go for it. All right, let's see what we can do. Number 2. The sales tax rate in Georgetown is 6.25%. So this is a add-on percent, because a tax is increasing the amount of money. Add-on percent. If he purchases 3 lamps for $39.95 each, as soon as you see that, you should think to yourself, oh boy, I need to figure out how much these are in total. So we're going to have to total at some point, total them. And a couch for $949.99. How much sales tax does he owe? And what is the total cost of the items? Well, right away you should say, okay, 3 lamps. So the lamps are going to be 3 times $39.95, because we got 3 of them at that price, which is $119.85. Then we did the couch, which was $949.99. What are we going to do to these two amounts to get our total spent? We're going to add them. So we have $119.85 plus $949.99. It gives us $1069.84. This now will become our whole because it's the original amount we spent. Let's go ahead and talk about our part, our whole, and our percent. Our part is unknown. We're looking for it. Our whole is 1069.84. Now our percent, you can do 2 ways. you can either say, okay, it's 6.25 out of 100, and then you would have to add. In this particular problem, I would probably use this method because it asks 2 questions: how much sales tax and what is the total cost after the sales tax. But if you were working smarter, not harder, you would do 100% plus the 6.25% to give you a grand total of 106.25%. Now you can always do that, but because this one has scaffolded questions, you're going to have to add or subtract at some point. So let's do the working harder way just for this one. So we have this information. So we have part equals whole times percent out of 100. Then we have our part is X. Our whole is 1069.84. Our percent is 6.25 out of 100. Now we can solve. 1069.84 times 6.25 out of 100 should give you 66.865. And yes, we're going to write down the whole number, and we're not going to round anything yet. We're going to keep that whole number there. Now, this is our tax amount. So for part A, we can say tax equals, now we can round this, 66.87, because the 5 tells us 6 to round up. But when we do part B for the total, we need to do the unrounded amount. So we're going to do 1069.84 plus 66.865. And let's see what that gives us. 1069.80. Oops. I put it in my calculator wrong. 66.865 plus 1069.84. We should get 1,136.705. Which means our grand total money spent, rounded to money, because yes, you have to do that, would be 1,136.71, because that 5 tells that 0 it wants to be a 1. All right. I hope this helps. Do we care if you do working smarter or harder? Absolutely not. But if you get it, go for it. If you don't, no worries. If you have questions, please let me know. Can you guys go ahead and pause the video and try 5 and 6? Then unpause it and check your answers. I did the working smarter, not harder method here, so I took 100% and I subtracted 15% because it was a percent off, which meant it was a discount. Now, you could have used the 15% and then subtracted because it's a discount, but either way, you should have ended up at the same answer. All right, pause the video, try the next one. Here is this problem. Again, it is a discount, therefore it is decreasing. Again, I did the working smarter, not harder way, so I took 100 and subtracted 30% to give me 70%, which is what I used. If you use 30% and then subtracted, you still should have gotten the same answer. Be sure to add that 0 because you're talking about money. If you don't add that 0, you'll probably lose a half a point because we need to know that you understand how to write dollars. Okay, guys, go continue following the instructions on Google Classroom and let me know if you have any questions. Bye.